Modern bombs are smart, much smarter than you think they are. The Joint Direct Attack Munition, or JDAM, makes what's known as dumb bombs smarter, and that means making them more lethal. We're going to take a look at the methodology behind the system and show you why it's so effective. The Joint Direct Attack Munition is a guidance tail kit that changes existing unguided free-fall bombs into accurate, adverse weather-smart munitions. This is done with a new tail section that combines an inertial navigation system and a global positioning system guidance control unit, which greatly improves navigation and effectiveness in any weather condition. JDAM is a joint U.S. Air Force and the Department of Navy program. Operation Desert Storm in Iraq highlighted a shortfall in air-to-surface weapon capability. Difficult weather conditions limited the use of precision-guided munitions. Unguided weapon accuracy was also degraded when launched from medium and high altitudes. Research and development of an adverse weather precision-guided munition began in 1992 as a response. JDAM kits were first delivered in 1997, with operational testing conducted a year later. Unguided weapon accuracy was also degraded when launched from medium and high altitudes. Research and development of an adverse weather precision-guided munition began in 1992 as a response. JDAM kits were first delivered in 1997, with operational testing conducted a year later. Warhead is the payload. It allows for the use of accurate air-to-surface weapons against high-priority, fixed and relocatable targets from fighter and bomber aircraft. Guidance is from a tail control system and a GPS-aided internal navigation system. This navigation system works with transfer alignment from the aircraft that provides position and velocity vectors from the aircraft systems. The tail kit includes adjustable tail fins, a control computer, an inertial guidance system, and a GPS receiver. Both the receiver and the inertial guidance system lets the bomb locates itself in space. The GPS receiver works out its position by interpreting GPS satellite signals, while the inertial guidance system monitors the bomb's movements, tracking its path from where it was launched. After being released from a plane, the JDAM autonomously navigates to the designated target coordinates. These can be loaded into the aircraft before takeoff, manually altered by the crew before weapon release, or automatically input using target designation with onboard aircraft sensors. In the air, the JDAM's GPS receiver processes signals from GPS satellites to keep track of where it is. Like with other smart bombs, the control system adjusts the flight fins to steer the bomb in the right direction. In its most accurate mode, the JDAM system will give a weapon circular error probable of 5 meters or less during free flight, assuming GPS data is available. If GPS data isn't received, the bomb will achieve a 30 meters SEP or less for free flight times up to 100 seconds. 324 The reason the system works fine, even in bad weather, is because it gets all its information from satellite signals which aren't blocked by cloud cover or obstacles. The bomb doesn't have to see anything at all to find its way to the target. Another advantage is that at around $20,000 per tail kit, this retrofit method is much more economical than $120,000 plus laser-guided bombs. JDAM is currently compatible with the following aircraft: B-1B, B-2A, B-52H, AV-8B, F-15E, F-A-18C DEF, F-16CD and F-22. Follow-on integration efforts are currently being delivered or planned to evaluate compatibility with the A-10, F-35 Joint Strike Fighter, and MQ-9 Reaper drone. This combination of the JDAM stealth and accuracy has revolutionized air warfare. Growth of the JDAM family of weapons expanded to the Mark 82,500-pound version, with development starting in late 1999. The 500-pound JDAM-er, or extended range variant, features a modular add-on wing kit, which uses small-diameter bomb glide technology. The wings unfold in flight and increase the range of the weapon threefold from 15 miles to more than 45 miles. This modular designed wing kit can be easily upgraded with improved technologies and other modular enhancements such as laser sensors and anti-jamming countermeasures. JDAM-ER was tested at Woomera in Australia in 2006 and 2008 with great success, paving the way for the start of its production. Following this, the JDAM-ER version of the weapon system entered service with the Australian Air Force in 2015. The addition of the DSTO's wing kit significantly improved JDAM's range, allowing the engagement of long-range targets. In 2006, the departments of the Navy and Air Force planned a low-cost, non-developmental enhancement to the 500-pound JDAM to address moving targets. Open competition and source selection were completed, and the Navy awarded a contract to Boeing for a direct attack moving target capability, and the material solution was laser JDAM. Known as LJDAM or GBU-54, it's a 500-pound dual-mode weapon that couples the GPS-INS precision of the JDAM and laser-designated accuracy of a laser-guided bomb into one weapon. LJDAM also provides added capability and flexibility to the fleet's existing inventory of precision-guided munitions to satisfy the ground-moving target capability. The Navy has also developed the GBU-56 laser JDAM for the Blue 109 penetrator to replace the legacy GBU-24 Paveway 3 weapon systems and improve performance in highly contested environments. Its modular design enables the installation of a low-cost laser sensor kit on an existing JDAM in the field, needing only a few minutes to do so. On top of the all-weather GPS-INS capability, laser JDAM can strike targeted opportunities, including mobile and naval ones. Boeing delivered laser JDAMs to the U.S. Air Force in the spring of 2008. The system is used on the Air Force's F-15E and F-16, and the U.S. Navy's FA-18 and AV-8B platforms. In 2022, the Pentagon announced sending precision aerial munitions to Ukraine as part of a $1.85 billion package to aid with the conflict in their nation. Ukrainian air forces have been successful in using this type of aircraft bomb. These bombs have allowed hitting targets without entering Russian air defense zones. Ukraine received the extended range version, giving it the potential to hit from 72.4 kilometers. Bombs were then integrated into MiG-29 fighter aircraft. For over 20 years now, the JDAM has proved itself to be a highly effective upgrade kit for existing bombs. Its relatively low price and highly accurate results in all weather have made this the perfect weapon to be used by nations across the world. Currently, 26 countries employ the JDAM to be used to upgrade their bombs, making them smarter and highly lethal. What do you think about the JDAM bomb? Let us know in the comments, and please like this video if you've enjoyed it. If you want to see more videos like this one, then subscribe to Spotlight for more. Thanks for watching.